Hi everyone, I am Dr. N. Sambat Kumar, Associate Professor and Head Department of Chemistry, SSM Institute of Engineering and Technology. In this session, I am going to discuss about some of the topics in the unit called as fuels and combustion. Fuels can be defined as any substance on combustion. If it releases energy, then we can call them as fuels. Fuels can be classified as primary fuels, secondary fuels. So before going to the classification, the fuels or the substances on combustion, if it releases energy, then we can call them as fuels. Normally the basic reaction taking place in the combustion of fuel is the carbon present in the fuel combines with the oxygen to produce carbon dioxide and energy. This is the basic reaction taking place during the course of combustion of any fuel. Normally elements like carbon, hydrogen, nitrogen, oxygen and sulfur are the major constituents of any fuel. The classification of the fuels can be done on the basis of two things. One is based on the source, the second one based on their physical state. First, based on the source, the fuels can be classified into two types. One is called as a primary fuel, the next one is called as a secondary fuel. The primary fuels are otherwise called as direct fuels. These fuels are obtained from the source without doing any physiochemical processes. The examples for the primary or direct fuels are wood, crude oil, etc. The second one is called as a secondary fuel or derived fuel. The name itself tells these fuels are obtained from the source after some physiochemical processes. That's why they are called as derived fuels. So these fuels are obtained after doing some physiochemical processes on the primary fuels. The examples for the secondary or the derived fuels are coal, diesel, petrol, etc. Next one, the classification of the fuels based on their physical state. Solid, liquid and gaseous fuels. Out of the three, gaseous fuels are found to be more selective or more preferred one because of its advantageous properties. Next, what are the characteristics of an ideal or a good fuel? A good fuel should have a high calorific value. Calorific value can be defined as the total amount of heat liberated during the combustion of a unit volume of fuel is called as calorific value. Next, a good fuel is that which gives more heat per unit mass. So the thing is, any good fuel should give more amount of energy per unit mass, then it can be called as ideal or a good fuel. Next, a good fuel should have a low ignition temperature. Ignition temperature can be defined as the minimum temperature at which the fuel starts burning smoothly is called as ignition temperature. The next point is, an ideal fuel should not pollute the environment by releasing gases like oxides of nitrogen and oxides of sulfur. Next, a good fuel should not give any undesirable byproducts, and they should not give any residual after burning. And the last one, a good fuel, it should be available and easy to transport. So these are the characteristics of an ideal fuel or a good fuel. Next comes a solid fuel, coal. Coal belongs to a category called as the fossil fuels. So in coal, there is a process is called as coalification is there. Coalification means the process of conversion of vegetable matter into coal is known as coalification, or otherwise it is termed as metamorphism. So metamorphism or coalification is the process of conversion of vegetable matter into coal is termed as coalification or metamorphism. Next, classification of coal. Coal can be classified on the basis of the content of the fixed carbon. So the fixed carbon is the one which gives a valuable information about the quality of the coal. So based on the percentage of the fixed carbon, the coal can be classified as like in the sequence, starting with wood, next peat, lignite, bituminous coal. This coal which contains 90% of carbon, then steam coal and anthracite coal. Anthracite coal is the best coal which is available because which contains the highest percentage, 95% of carbon in it. Next comes the analysis of coal. Coal has to be analyzed for the following reasons. First one, for price fixation. Second one, commercial classification. And the third one is industrial utilization. So coal has to be analyzed. The analysis of coal has to be done for the three reasons: for price fixation, commercial classification and industrial utilization. These are the three purposes for which any coal has to be analyzed. The analysis of coal can be done in two ways. One is called as a proximate analysis. The next one is called as ultimate analysis. Proximate analysis is the analysis in which the data collected vary with the procedure, and it is an empirical analysis. It doesn't give any informations about the authenticity of the results obtained. Proximate analysis involves the determination of percentage of moisture content, volatile matter, ash content and fixed carbon. Moisture content. Moisture has its own significance in the performance of any fuel. The moisture content can be estimated by adopting the following procedure. 1 gram of a powdered and air dried coal sample in a crucible is heated at about 100 to 150 degrees Celsius in an electric oven for an hour. The loss in weight of the sample is found out and the percentage of moisture is calculated. So here 1 gram of powdered coal and air dried coal sample is put it in a crucible and it is heated at 100 to 150 degrees Celsius in an electric air oven for an hour. The loss in weight of the sample is found out and the percentage of moisture is calculated. The percentage of moisture equals to the loss in weight of coal divided by the weight of air dried coal into 100, which will give you the percentage of the moisture in a given coal. Next, the significance. What are the significances of the moisture? High content of a moisture which reduces the calorific value and which increases the consumption of the fuel. So once the increases the consumption of the fuel goes, it affects the productivity, the cost of production and everything. So here, what are the major significance of the moisture is which reduces the calorific value of a coal and which increases the consumption of the fuel. Next one's the volatile matter. The volatile matter are lower hydrocarbons, carbon monoxide, carbon dioxide and nitrogen are the examples for volatile matter. This volatile matter can be measured or determined by adopting the following procedure. The residual coal sample is heated in a closed crucible at 950 degrees Celsius for 7 minutes in a muffle furnace. The loss in weight is found out. So the percentage of volatile matter equals to loss in weight of coal divided by the weight of moisture free coal into 100. Next comes, what are the significances of the volatile matter? If a fuel which contains lot of volatile matter which provides easy ignition and volatile matter reduces calorific value and it produces yellow smoky flame. So easy ignition, low calorific value, yellow smoky flame are the significances of volatile matter. The next one, ash content. Ash is the combination of a mineral matter like silica, alumina, ferric oxide, calcium oxide and magnesium oxide with organic matter. The ash content of a coal can be estimated by doing the following procedure. The crucible with the residual coal sample is heated without lid at 750 degrees Celsius for 30 minutes in a muffle furnace. The loss in weight is found out. From the loss in weight, we can find out the percentage of ash present in a given coal sample. The weight of ash formed divided by weight of dried coal into 100. So next comes the significance. High ash content always lowers the calorific value. High ash content lowers the calorific value of the coal. Last one, fixed carbon. Fixed carbon can be estimated by subtracting the sum of the percentage of moisture, volatile matter and ash content. So fixed carbon percentage equals to 100 minus percentage of the sum of the percentages of moisture, volatile matter and ash. Next, significance. The significances of fixed carbon is always high percentage of fixed carbon provides high calorific value to the fuel or coal. So here in proximate analysis, the factors like moisture content, volatile matter, ash content and fixed carbon can be estimated or calculated. Next comes ultimate analysis. Ultimate analysis, it involves the determination of carbon, hydrogen, nitrogen, sulfur and oxygen in pure and dry coal. From the name itself knows, the ultimate analysis, we are going to follow a standard and well known and well accepted procedures to find out the percentage of carbon, hydrogen, nitrogen, sulfur and oxygen